So I know we're kind of high level at this point. We're kind of, talking around the subject and we're not getting down into the meat of it. And you need to hang on with me a little bit here because we still need to talk a little bit of theory before we actually get into it. I'll give you a set of steps for hijacking. It'll work and you can play around with it, or you could just like run straight to HPing and start playing around with that and not understand what you're doing. If you do that, what's going to happen is you're not going to be able to make up a new attack. Because the old attacks, once the defenders figure it out, they're not going to work anymore. You need to be able to be creative about this. You need to think a little bit deeper than just, okay, well, I'll just use HPing. I mean, it's a great tool, don't get me wrong, and it works in a lot of cases. But think about the next version and the next version and the next version. So sequence numbers is kind of the next step in this. We want to know a counter that steps forward throughout our conversation to control that conversation. It also helps with the reassembly of that conversation if there's some fragmentation across the stream. We have no idea what the size is going to be. It's not predictable. The only time it was ever predictable was actually in ATM cells, and they were a fixed size. We don't do that with TCP IP. We say it's variable size and length. And with V6, we actually have what's called jumbo. So we go from standard packet size to jumbo packet size. But in all this, when we talk about sequencing, what we're saying is, what's the flow of data across this? And we, as the attacker, we want to successfully guess the sequencing and jump in at that area. Okay, so let's talk a little more about sequencing. Many connection-oriented protocols use sequencing. TCP uses it. Protocol data units are numbered sequentially, and they increment as they go along. What this does for us is it gives us ordered delivery so they can do reassembly quickly and efficiently, flow control so that we can respect the fact that there may be congestion, and error control in case a packet gets dropped. We have to include some way to identify that connection, a unique connection identifier. Usually what we do is the pairing of the IP address with the port number and the sequence number. All of that together gives us a predictability. That's identifying that connection. But remember, those are all at different layers, so we can start playing with the game there. So the attacker, when they're looking at the sequence numbers, they either have to know it, so it starts. Let's say, for argument's sake, that you're non-random and your server initiates. The Windows NT4 server prior to Service Pack 3, prior to Service Pack 2, I think, actually started with a particular sequence number. It was always starting at this number. So if you could reset the connection, you could know, okay, the first piece in that connection is going to be this sequence number, and you could jump into the stream. You could also force it to be known. You could advance it or slow it down in some way, shape, or form and say, I know that this is what's going to happen next. So you can force that to be known. And then finally, there's predicting within a range. You say, well, how would predicting in a range work? Well, what I could do is I could craft a whole bunch of packets. So let's say that I know that the range is going to be, for the next step in the sequence number, is going to be between 1 and 100. And there's like 100,000 after that. 1 to 100. I can create 100 packets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 100. And I can send all of them to you at once. If I know that they're in this range and I know that's about to occur and I send all those packets out, if I hit it just right, I beat the other guy to the punch and I take over. That's very noisy. What we would like to do is we would like to know it, or we'd like it to force it to be known. In other words, force a particular number to occur. Not to send a spray of packets out there, because then we're going to get caught. Remember, spoofing is pretending to be another user or machine to gain access. You're not taking the other user offline. You're pretending to be somebody else at the packet level. Hijacking relies on the legitimate user to do the authentication and the connection and get all that set up, and then the attacker jumps into the stream. What we want to do is we want to do this after the upper layer authentication has occurred. So if somebody was HTTP authenticating up here and we could jump into the stream down here, we win because they've already authenticated for us and we're good. Now, one of the tools that you want to use is called EtherCap. I like that. Hping is another one of the tools out there. I can't remember which one of those is the best tool from an exam standpoint, so I would say use both. EtherCap, Linux only tool is, actually I won't say it's a Linux only tool, I will say it's the best tool on Linux for doing what you need to do when you're taking advantage of this session. The configurations on this you need to take some time to learn how to configure this tool. It's not very straightforward in my opinion. Okay, so now here are the steps. So I've been torturing you all along, and now I'll go ahead and give you, it's all been stick, and now it's a little bit of carrot. So track or predict a connection. That means that you're listening. That's why we did the sniffing first. Desynchronize the connection. We can establish but not transmit. So what we do is we shrink the amount of data that's being transmitted down to 1 or 0. So if we can reduce it down to 0, we're ready to go. Force the ACK forward. We're going, okay, we're at 0 now, or we're at this number, and we're not moving forward. Now we're going to move 1 at a time, and we're going to keep on moving slowly, 1 at a time. And you agree, I agree, 1, 1, 1, 1, 1, or 0, 0, 0, 0, 0 in that session. We could reset and get a new sequence number, but usually what happens is that forces us to re-authenticate. And then the attacker injects or receives the data at that point. They can see what's in the stream. And this is when you're looking in Wireshark, you want to look down in that ASCII area so you can see what data is being transmitted. Now you have to be really quick. Now, if you talk about Mitnick, his attack was about predicting the receiving side of it. You don't need to know about the Mitnick attack. You need to know that there is a very famous attacker out there that social engineered people into giving him information. Okay, now, it's going to hurt a little bit, but we need to look at where we are in the session. What state are we in based upon the flag? So I wanted to get that out of the way up front. This diagram talks about the possible different active open sessions, knowing what's going to happen next. I don't expect you to memorize this here, but I want you to know that it does exist, and you have to say, okay, where are we in this process? And if you can figure out where we are in this process, you can know what's coming next. So have we received, we're listening at this point, have we received the SYN? Are we ready to send the SYN in the ACK? Where are we in the conversation? And go all along your diagram, and once you've figured out where you are in the session, or predict where you're going to be next in the session, then you can do decent hijacking. Now, there are two kinds of session hijacking. There's the active one where we inject, and there's the passive one where we record. In the active one, we take over and we corrupt the integrity. In the passive one, all we're doing is we're collecting all this data for the next time. We're going to compromise confidentiality either now or in the future. Okay, so which one are we doing? Are we doing hijacking or are we doing spoofing? Remember, hijacking relies on the legitimate user to connect and authenticate and then take over the session. Do you have authentication credentials, yes or no? Can you get them, yes or no? If you can get the authentication credentials, you don't need to do hijacking. You spoof. Spoofing, you're attacking to be, you're pretending to be the other person or the machine to gain access. You probably have some credentials. So that's hijacking and spoofing. The tools are EtherCap and Hping.